Very good morning, friends. So, we are going to start off with the revision of your paper 3, which is your 100 marks paper on quantitative aptitude. Now, you all know the split. The paper comprises of 3 segments: part 1, max, part 2, logical reasoning, and part 3, statistics. In max, you see the weightage is 40 marks, logical reasoning weightage 20, and stats weightage 40. Our agenda for today is going to be coverage of this region of 40 marks, which is for statistics. Okay, so how we will be going about this particular revision for today? Let's understand it quickly before we get started. Friends, every topic we will be starting off with the formulae first. So we will first have a quick recap of all the formula, all the concepts that are there in that particular topic, and we will have a quick note of all the particular important aspects, right? And after the formula revision is done, I will be picking and giving you certain questions which are which are to be practiced for your examination purpose, right? Some could be basic questions, some can be advanced questions. So we will be having a mix of basic and advanced questions for practice, right? So this is going to be our agenda for today for revision. Now that being said, let's get started. Before that, I think someone's entering the meeting. Okay, no one. Right. Now in statistics, we are going to start focusing based on, is someone entering? We are going to start focusing based on the areas of importance. If you look at the areas of importance, first it is going to be measures of central tendency and dispersion. Okay. Second, correlation and regression. Third, probability and theoretical distribution. Fourth, or the last, being index numbers and theory portions, which is first chapter, statistical description of data. Okay, so this is going to be the order of focus, and this is the order in which we will be doing the practice for today as well, right? So let's get started. First, measures of central tendency. Now friends, what are the measures of central tendency? There are 3 measures of central tendency: mean, median and mode. Okay, and when it comes to mean is further classified into 3 types: arithmetic mean, geometric mean and harmonic mean. Remember, when they ask you measures of central tendency, it is only 3: mean, median and mode. However, whenever we are speaking about mean, it is covered into AM, GM and HM. When they use the word mean as it is, we should always remember it always refers only to arithmetic mean. Okay. Now, when is mean used? Mean is a numerical measure. So, mean is a numerical measure, whereas median and mode are positional measures. Now, mean is used wherever you want a numerical representative of the data. and in case of most of the cases we will be using arithmetic mean, whereas geometric mean and harmonic mean have specific usages. So where is geometric mean used? Geometric mean is used when the data is given in percentages, ratios, etc. Okay, and harmonic mean is used when the data relates to speed, distance and time. Okay, so when the data is in percentages, please remember it is geometric mean which is relevant. When the data is relating to speed, distance, time, then arithmetic ratios, etc., then harmonic mean is going to be relevant. Okay, on all other cases you can use arithmetic mean, right? So now, given this basic rules, let's get started with the formulae. Now formula, I am going to split it into three categories: non-frequency type, discrete frequency type and continuous frequency type. Now what is this non-frequency type? Where the data is given plainly in forms of numbers like 31, 22, 20, 33, so on. Discrete frequency is where data and frequency column is given. So you have data as isolated values. Discrete data, the values will be like 10, 11, 12 and you will have frequencies respectively 2, 1, 3, etc. And continuous frequency is where data is given in the form of class intervals. So 10 to 20, 20 to 30. Okay. So 3, 2, so on. Right. So these are the three categories in which I am going to split the formula. Now let's start with the formulae. First, formula for arithmetic mean. Now how to calculate arithmetic mean in case of a non-frequency type? Sigma x by n. Sum of observations divided by total number of observations. Whereas when it is discrete frequency, it is sigma fx divided by sigma f, where f is the frequency and the value will get multiplied and then we need to take the total. So we will have a separate column of fx where we will multiply all the values and then take the total in the numerator. Likewise, in the continuous frequency, it will be sigma fm divided by sigma f, where m represents not the value of x directly, here it represents the mid value. It represents the mid value. Remember, whenever you have a continuous frequency data, you have to check whether the class intervals are exhaustive. Okay, so when you are having the intervals, check whether they don't have any gap. The intervals don't have like 10 to 20, 20 to 30. There should be no gap between one interval and the other. If you have a gap between two intervals, then you need to convert them into class boundaries. Okay, convert them into class boundaries by adding and adding the half of the gap in both sides. Okay, so once you convert to class boundaries, then you will be able to find out the mid value. For example, if the intervals are something like this: 12 to 20, 22 to 30, 32 to 40. Now they are not exhaustive. So now the gap is between 20 and 22, the gap is 2. So half of the gap becomes 1. So now what I need to do? I need to add and subtract 1 on both sides. So 12 minus 1, 11, to 20 plus 1, 21. 21 to 31, 31 to 41. These revised values are called as class boundaries. Okay, they are called as class boundaries, and these boundaries will be used whenever you are doing your calculation for any continuous frequency data. Clear? So this is your first set of formula when it comes to arithmetic mean. Next we move on to geometric mean. What is geometric mean? Geometric mean is referred to as nth root of product of observations. Nth root of product of observations. Now how to find out geometric mean? We have to take in case of non-frequency data, take the observations within the root. So the values n1, n2, n3, so on. All the values will be taken, x1, x2, x3. Okay, you will multiply the values and outside you will take the nth root. Okay, outside you need to take the nth root. Similarly, if it is discrete frequency, the frequency will be taken as the power. So, root of x1 to the power f1, x into x2 to the power f2 into x3 to the power f3, so on. And the root will be sigma fth root. Okay, whatever is the value of sigma f, that many roots we need to take. Similarly, the formula remains the same. Here, instead of x, we are going to use the mid value, m1 to the power f1, m2 to the power f2, m3 to the power f3, so on. And this is going to be sigma fth root. Right? So, this is the formula for geometric mean and in case of all the three types of distributions. So, we move on to the next mean, which is harmonic mean. What is harmonic mean represented as? It is the reciprocal of arithmetic mean of reciprocal of observations. Okay. So, now to find out your harmonic mean, the formula is going to be n divided by sigma 1 by x. So, the values given, you need to take the reciprocal of the values, total the reciprocals and then apply the formula. Okay. When it comes to discrete, it is going to be sigma f divided by sigma f into 1 by x, or which can be written as sigma f by x. Okay. Similarly, continuous, same formula as discrete, just that in case of continuous distribution, the value used will be the mid value. Okay. So, this summarizes the three types of mean, which is your arithmetic, harmonic and geometric mean. Always remember, your question will be silent if you have to use arithmetic mean. If the question is going to be, just a minute. Yeah, so let's continue. So, like I was saying, if the question is silent, it is always going to refer to arithmetic mean. If the question gives you question on speed, distance and time, it is always harmonic mean. If the question is on percentages, then it refers to geometric mean, right? So, this is going to be your understanding for all the three types of means. Now, moving on, we are going to move to the next measure, which is median. Median is a positional measure. It is the middle value or the central value in terms of the position of observations. Okay, that is how you have to remember. It is the middle value or the central value in terms of position. Now, how to find out the median in case of a non-frequency distribution? In case of non-frequency, you have to check whether the number of observations are odd or even. Okay, if the number of observations are odd, then median position is equal to n plus 1 by 2th position. Okay. Similarly, if the number of observations are even, then the median positions are 2. What are the two positions? N by 2, comma n by 2 plus 1th position. N by 2 comma n by 2 plus 1th position. Now remember, whenever you have odd only one position, now you need to arrange the values in their ascending order. You have to arrange the values in ascending order, and once you arrange them in ascending order, you need to ensure that so once they coming back to the formula, once you arrange the values in ascending order, you need to use the position number directly, and that position number, whichever value is corresponding to that position number, will be the value of the median. Right? Remember, the formula is only to identify the median position and not the median value. Okay? Now, when it comes to the even positions, you need to take the average of values of the two positions. Okay, so this is going to be the formula for median in case of a non-frequency distribution. Now, when it comes to discrete frequency distribution, okay, now the formula is going to remain the same for discrete frequency distribution. Same for odd number of observations, n plus 1 by 2th position. For even number of observations, n by 2 comma n by 2 plus 1th position. But we will be using cumulative frequency. Okay, cumulative frequency is nothing but summation of frequencies or aggregate of frequencies. So we will be using the cumulative frequency to find out which position corresponds to the median position. And in case of continuous frequency, again we will be using the cumulative frequency column. Okay, now when we are using the cumulative frequency column, here the formula is going to slightly undergo a change. What will be the change in the formula? Okay, the note is having some issue, so let's continue as it is. Right. So in case of continuous or cumulative frequency distributions for median, okay, we are going to use the cumulative frequency column. Now, how do we use the formula? The formula is going to be L plus. Just excuse me for a minute, I think. Yeah, so let's continue. Formula is L plus n by 2 minus n1 divided by n2 minus n1 into C. Okay, where L is your lower limit of the median class. N by 2 represents the total number of observations divided by 2, which is your median position. Okay, even if the positions are In decimal, no problem. Okay. Now in that case, please use the decimal value as it is. Do not round off the decimal values. Now N1 is the value preceding the median class in the cumulative frequency column. Similarly, N2 is the value succeeding the median class in the cumulative frequency column. Okay, or succeeding N1 in the cumulative frequency column. And C represents your class length. Right? So this is your formula for continuous frequency distribution. Now let's come to the last measure, which is mode. Now mode, what is mode? Mode is nothing but the most repeated value. Mode is the most repeated value. Now when you speak of most repeated value, when it comes to discrete frequency, non-frequency and discrete frequency, we don't have a problem. Non-frequency, just see which is the most repeated value and find the value of the mode. Similarly, discrete frequency, you can just see whichever has the highest frequency will be corresponding to the modal value. Whereas when it comes to continuous frequency, again we have the aspect to be remembered. When it comes to continuous frequency, you cannot use it directly, you need to use the formula. What is the formula? Formula is L plus, okay, F1 minus F0 divided by 2F1 minus F0 minus F2 into C. Now what is L? Lower limit of the modal class. How to find out the modal class? Whichever has the highest frequency is the modal class. Now F1. F1 represents the frequency of modal class. F0 preceding class frequency. F2 is succeeding class frequency. Remember, F1 is the modal class frequency. Okay. F0 is the preceding frequency, F2 is the succeeding frequency, and C is as usual your class length. So these are your formula for mean, median and mode. Right? Now to certain important aspects, important properties for us to remember. Now let's quickly recap the properties. What are all the main aspects to remember here? Always remember the first rule. Arithmetic mean will always be greater than geometric mean, which will be greater than harmonic mean for any set of observations. However, if all the observations are the same, then arithmetic mean will be equal to geometric mean, which will be equal to harmonic mean. This is when the observations are same. Now, the relationship between arithmetic mean, geometric mean and harmonic mean is given as GM is equal to root of AM into HM. Root of AM into HM. Okay. So, this is your formula for identifying the three means using a relationship. Now, if the relationship is going to be between mean, median and mode, when I say mean, it is always referring to the arithmetic mean. So, if it is between mean, median and mode, then it is given as mode is equal to 3 median minus 2 times arithmetic mean. Okay. So remember, when all observations are the same, then mean, median and mode will all be equal. Whereas when observations are different, then you can use these empirical relationship to find out the values. Right? Now, the next important formula in terms of properties for you to remember. Very, very important property, change in origin and change in scale. change in origin and change in scale. Now when it comes to change in origin, okay, now what is change in origin? Origin is nothing but addition or subtraction of the same value to all the observations. Okay, and when it comes to change in scale, it is multiplication or division of a given value to all the observations. Right? Now, how do we remember the rule of change in origin and change in scale? For measures of central tendency, which is AM, GM, HM, mode, median and mode, it is affected both by change in origin and by change in scale. So, affected by change in origin and change in scale. Now, when you say affected by change in origin and scale, the relationship is going to be given as y is equal to a plus bx, where a represents the origin part and b represents the scale part. So, for any measure of central tendency of y, we can use the formula as a plus b into central tendency value of x. This central tendency value can be mean, median, mode, AM, GM, HM, anything. Okay. So, the equation is y is equal to a plus bx. Clear? Okay. So, these are the important formulae relevant properties that you have to remember from central tendency chapter. Okay. So, this summarizes your chapter on central tendency. Right? Now, if you are clear with the basics so far, we are going to start with some quick questions from central tendency. Okay. So, the first question for you to practice is, calculate median and mode. Okay. So, I am going to give you the distribution. You can directly calculate the median and mode.
Ma'am?
Yes.
Ma'am, can you please explain again the change in origin and scale, ma'am?
Okay. Change in origin refers to addition or subtraction of a value to all the observations. Okay, if phi is added to all the observations, then it is change in origin. Whereas when you multiply or divide a value with all the observations, then that is change in scale. Okay, say if 3 is multiplied or 2 is multiplied like that, then it becomes change in scale. Central tendency is affected both by change in origin and change in scale.
Okay, ma'am. Thank you.
Okay. Go ahead, calculate the median and mode for this question. Are you done with median, friends? So, the cumulative frequency will be 2, 5, 5 plus 1, 6, 6 plus 4, 10. So, value n is 10. Therefore, your n by 2 will be 10 by 2, which is 5. What is n1? n1, now remember 5 is exactly here. So, this becomes n2 and preceding class interval becomes n1. And corresponding to n2 will always be the median class. Remember this rule always. n2 is the class which n2 is the line in the cumulative frequency which will always correspond to the median class. So, your median class is 31 to 40. Okay. Now, because we have the observations which are not continuous, let's convert them to exhaustive boundaries. So, you will get 10.5 to 30.5, 30.5 to 40.5, 40.5 to 50.5 and 50.5 to 60.5. Now, in this we are going to use 30.5 as the basis. So 30.5 plus n by 2, 5, minus n1, which is 2, divided by n2 minus n1, again 5 minus 2 into C. What is C? C is the class length of the class boundaries. Class interval has to be taken based on the class boundary. Now your class length will not be 40 minus 31, it will be 40.5 minus 30.5, which is 10. Okay, it doesn't matter if the boundaries are, if the lengths are unequal, don't worry about it. Just take the length whichever is corresponding to your class. Okay, so given that, what will be your median value? Can you give me the answer for the median value, friends?
40.5, ma'am.
How much?
40.5.
How come 3? Yeah, okay. 40.5, right. So median value will be 40.5 exactly. Okay, 40.5 is the median value. Now coming to mode, normally what formula we will use? We will use L plus n by 2, L plus f1 minus f0 divided by 2f1 minus f0 minus f2 into C. Here, remember your highest frequency is f1. Okay, highest frequency is f1, so 4 becomes f1, 1 becomes f0, but what will be f2? We do not know how to find f2 here. So when either f0 or f2 is missing, then for calculation of mode, you have to use the empirical relationship. What is the empirical relationship formula? Mode is equal to 3 median minus 2 mean. The question will not tell you use the empirical relationship. You need to identify where it would be relevant. Here, we cannot use the formula because we are we are not having the next interval. You cannot assume it as 0 and continue. You have to now resort to the empirical relationship. So now here we have the median value already 40.5. Find out the arithmetic mean. Use sigma fx by sigma f, use the mid value, find out the arithmetic mean and then calculate the value of mode. Go ahead, calculate and give me the answer. This will be 3 into 40.5 minus 2 into, calculate the arithmetic mean. So we are getting the mean as 41.5, giving us the final value of mode as 38.5. Okay. So this is your calculation of median and mode. Otherwise the formula would be clear, I believe. Okay. So is this example clear, friends? Yes. Now I am going to another question of calculation of missing frequency. Now let's take a question. Median of an observation of a set of observation is 32. Okay. Now the observation is given as 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60. The observations missing frequencies are 10, 25, 30, question mark and 10. Now in this case, if you want to find out these two missing frequencies, okay, and you are also given that total frequency or total value of observations, total number of observations is, let's take 100. Now if you are asked to find out the missing frequency here, then we start with the median which is given. Now median is 32. When median is 32, we know that the median class will be 30 to 40. Okay, median class will be 30 to 40. And remember, in the formula, whatever corresponds to median class in the cumulative frequency column, 10. Median na we need to take cumulative frequency. Now 10, we do not know what is the next value, so I assume it as x. So I take it as 10 plus x. Then this is 10 plus 25 plus x, 35 plus x. 35 plus 30 plus x, 65 plus x. Then the next one I assume it as y, so 65 plus x plus y. And the last one 75 plus x plus y. Okay, so now we know that this total is going to be, this total is going to be 100. In other words, 75 plus x plus y is equal to 100. Okay, now coming back, the class interval, median class is going to be 30 to 40. Therefore, 65 plus x becomes n2. The preceding class will be taken, cumulative frequency will be taken as n1. Okay. Now go ahead, calculate the missing frequencies by applying the formula. What formula we are going to use? L plus n by 2 minus n1 divided by n2 minus n1 into c. Go ahead, calculate the values of x and y and give me the answer. So the value of x and y will be 9 and 16 respectively. I hope you have completed. Yes, so I assume others would have also completed. So let's continue. So similarly, your missing frequencies question can be from mean, mode, any of the areas, right? Remember, your starting point has to be the class interval which corresponds to the value of the mean, median or mode that is given. So with that as the starting point, you can calculate the value of the missing frequency. We now move on to the next question or next important type of question. The relationship between the two variables is given as 3x minus 5y No, why my system is slow suddenly. Okay. Equals 10. Okay. 3x minus 5y equals 10. Now, the mode of x is 3. What is the mode of y? Now how do we calculate? Whenever you have a relationship equation given, remember change in origin, change in scale rule. Y is equal to a plus bx. So we can write this equation as minus 5y equals 10 minus 3x or y equals minus 10 by 5, minus of minus becomes plus 3 by 5x. Now you can use this equation, directly substitute the value of mode of x. So mode of y will be equal to minus 10 by 5 plus 3 by 5 into 3. So 9 by 5, so answer will be minus 1 by 5. Okay, don't worry, the measure of central tendency can be negative. Okay, measure of dispersion cannot be negative, but central tendency can be negative. So don't worry about the answer. So answer is minus 1 by 5. Okay, now you can also directly substitute the value in this equation, but I do not recommend that, because when you go to measures of dispersion etc., you will have a change in approach. So it is always better to follow a same approach. Okay, so this summarizes measures of central tendency. Any doubts so far? Quick check, any doubts so far? Okay, so now I go to the next area, which is your partition values. So we are going to have a quick discussion on the partition values, which are your quartiles, deciles and percentiles. Okay, now what are quartiles? Quartiles are observations which are dividing the entire set of observations into how many parts? 4 parts. Okay, whereas how many quartiles exist? Remember, the number of quartiles or the number of divisors, items that divide, will always be 1 less than the number of parts. So 4 parts now, you will have 3 quartiles, which is Q1, Q2 and Q3. Similarly, deciles divide the observations into 10 equal parts positionally. And how many deciles do we have? We have 9 deciles from D1 to D9. Similarly, when it comes to percentiles, it divides into 100 parts. So we have 99 percentiles, which is P1 to P99. Okay. Now remember friends, whenever they ask you, one quartile represents, one quartile na, it represents 1/4 of a part. Okay. This is one quartile. Whereas how many quartiles exist? 3 quartiles exist. Okay. Similarly, one decile represents 1/10th of a part. One percentile represents 1/100th of a part. Okay. So remember, the number of parts is 4, 10 and 100. The number of partition values are 1 less than the number of parts. Now, of all these positions, median is the middle position, which is corresponding to quartile 2 or decile 5 or percentile 50. So Q2, D5, P50, all of these correspond to the median position directly. Okay, they are the exact middle position, so they correspond to the median position directly. Right? Now, how to find out quartiles in a, or quartiles or deciles or percentiles in a given distribution? Let's take an example. So I have a given set of observation. First, always whenever you are doing a positional measure, arrange them in ascending order. So 20, 22, 23, 24, 30 and 31. Okay. Now suppose I want to find out Q3. Now Q3 represents the third quartile. So one quartile is 1/4 of a part. So we are going to take n plus 1 by 4 into 3. 3 into n plus 1 by 4 for Q3. This is the position. So what is n? 1, 2, 3, 4, 5, 6. 6 is the value of n. So 3 into 6 plus 1. 7 by 4. What is the value? The value will be 21 by 4, which is 5.25th position. 5.25th position. Now when I speak of 5.25th position, it is the 5th position plus 0.25. What is the 5th position? 1, 2, 3, 4, 5. 30 is the 5th position. So 30 plus 0.25, which is the decimal, into 31 minus 30. The difference between the next position and the given position. So 31 minus 30. So 30 plus 0.25, which gives you the value as 30.25. This is the value of Q3. Now similarly you can do for deciles, percentiles, any formula. Now for example, if I am asking you calculate D40. D is D4. D is decile. Decile means it has to divide the observations into 10 parts. So we take it as n plus 1 by 10. D4 ingiradhanaala 4 into n plus 1 by 10. So your value will be 4 into 7 by 10. 2.8th position. 2.8th position. Now 2.8th position na, can you calculate? What is the second position? 22 plus 0.8 into the difference between the third and the second position, which is next position and the given position. 23 minus 22. So 22 into 0.8, 22 plus 0.8, which gives you 22.80. Similarly, you can apply this for any value in the question. Okay. Remember, whenever they are asking you positional measures, you have to remember the parts. That will give you the indication of how to calculate the position. Okay. Quartile na 4 parts, decile 10 parts and percentile 100 parts. Is that clear, friends? Any doubts so far? Okay, that's good. So now if you are clear so far, then let's start with the next area. So this summarizes your first part of the first area of discussion, which is central tendency. Now we are going on to the next measure, which is measures of dispersion. Right? So let's start with the measures of dispersion. Now, measures of dispersion are what values? They are the values which represent your deviation from the central tendency value. Okay, they represent the deviation from the central tendency. Now, measures of dispersion can be either absolute measures or relative measures. Absolute measures or relative measures. Now, when you speak of absolute measures, there are 4 measures. Measures of dispersion sonnale, there are only 4 measures. What are the 4 measures? Range, mean deviation, quartile deviation and standard deviation. I don't know why the journal is getting hung every time, but it's okay. Yeah, so coming back to dispersion. Right. So when we have the absolute measures, we have range, yeah, so okay, so I have retrieved some part of the note. Let's continue. Range, mean deviation, quartile deviation and standard deviation are the four measures of dispersion which are absolute measures. And for everything you will have coefficients. So coefficient of range, coefficient of mean deviation, coefficient of quartile deviation and coefficient of variation when it comes to standard deviation. They are all the relative measures. Remember, absolute measures will have unit of measurement, whereas relative measures will not have unit of measurement. Okay, so the question will give you two options, with unit, without unit. You have to be very careful. Depending on what measure is asked, you need to choose whether it is with units or without units. Okay, so marks, centimeters, idella unit of measurement. Right? Now let's come to the formulae one by one. What is the formula for range? Formula for range is nothing but largest value minus smallest observation. Okay, be it any measure, whether it is any method, whether non-frequency type, discrete frequency type or continuous frequency, it is the largest value minus the smallest value. And what is the formula for coefficient of range? Coefficient of range is nothing but L minus S by L plus S into 100. Okay, L minus S by L plus S into 100. So this is your first measure, range. Going to the next. The next measure is mean deviation. Now when it comes to mean deviation, if it is a non-frequency distribution, now what is mean deviation? It is the deviations from mean, and not just deviation or any deviation. We take it as absolute deviation. Absolute deviation, we will ignore the negative sign. We will ignore the sign. We will only take the value. So it is the average of absolute deviations. Okay. Now this absolute deviations will be taken generally from mean, but they can ask you to find out from median, from mode, anything. Okay, if they ask you to find out from median, do it from median. If it is from mode, do it from mode accordingly. If nothing is mentioned, do it from mean. So what is the formula? Sigma modulus of x minus x bar divided by n. This modulus is introduced to ensure that the deviations are absolute. X bar will be replaced by median or mode accordingly, whether when it is when it is mean deviation about median or mode. Now for discrete frequency and continuous frequency, the formula is sigma f into modulus of x minus x bar divided by sigma f. You should find the deviation, multiply with the frequency and then take the total. Okay. Now remember, when it is continuous distribution, the mid value will be considered. Okay. That is the only difference between discrete and continuous. Otherwise your formula remains the same. And coefficient of mean deviation will be mean deviation divided by arithmetic mean into 100. If it is about median, mean deviation divided by median into 100. About mode, mean deviation divided by mode into 100. Right? So this is your second measure, which is your mean deviation. Now coming to the next measure, which is quartile deviation. Okay, quartile deviation is otherwise known as semi-interquartile range. Semi-interquartile range. Okay, so what is the formula for quartile deviation? Q3 minus Q1 divided by 2. So if they ask you find out interquartile range, you should just do Q3 minus Q1. Semi-interquartile range na the quartile deviation, which is Q3 minus Q1 divided by 2. Am I clear? So check whether the question, suppose if they use the word interquartile range, check whether the question uses just interquartile range or semi-interquartile range. If they say interquartile range, you should do only Q3 minus Q1. Clear? How to find out Q3 and Q1 we have discussed just previously. So you can use that particular concept. Now, what is the coefficient of quartile deviation? Q3 minus Q1 divided by Q3 plus Q1 into 100. This is your coefficient of quartile deviation. Okay. Now we move on to the last measure, which is your standard deviation and the most accurate or the most important measure of dispersion. What is standard deviation? It is nothing but the root of average of squared deviations. It uses squared deviations. Okay. So what will be the formula? Standard deviation formula for a non-frequency type will be, this is the symbol for standard deviation. We call it as sigma. Okay. So if the symbol is given, it implies that it is standard deviation. Root of sigma x minus x bar the whole square divided by n. Whereas if it is going to be for discrete or continuous frequency, sigma is equal to root of sigma f into x minus x bar the whole square divided by sigma f. Okay, where x will be your mid value in case of continuous frequency. Now there is an alternate formula for this, and that is very important. Remember the alternate formula: sigma x square by n minus x bar the whole square, which is otherwise written as sigma x root of sigma x square by n minus x bar can be written as sigma x by n. So sigma x by n the whole square. Okay, so this alternative formula is going to be very important when it comes to standard deviation. Many questions are tested from this alternate form version of the formula. Okay. Now, when you want to find out the variance is nothing but standard deviation square. Coefficient of variation, both are different, friends. Variation is different from variance here. Coefficient of variation is given as standard deviation divided by arithmetic mean into 100. Clear? Now, the shortcut to find out standard deviation of n natural numbers. Standard deviation of n natural numbers is given as root of n square minus 1 divided by 12. Okay, the whole thing within the root. Let me draw the root a little bigger. N square minus 1 by 12. Okay, that reminds me how to find out arithmetic mean of n natural numbers. It is nothing but n into n plus 1 by 2 divided by n. So n and n will get cancelled. Answer will be n plus 1 by 2. So when they ask you arithmetic mean of n natural numbers, it is n plus 1 by 2. When they ask you standard deviation of n natural numbers, it is root of n square minus 1 by 12. Am I clear? So these are your formulae that are going to be relevant from standard deviation perspective. Can I continue, friends? Any doubts so far? Okay, so I assume you clear. Now let's come to certain important properties of dispersion. First, relationships. Okay, how to remember the relationships? Range is 2 times standard deviation, or SD is equal to half of range. Anytime, anyways you can take. Okay, when I say equal to, it is not exactly equal, it will be equivalent approximation. Next, mean deviation is equal to 4 by 5 standard deviation, and quartile deviation is 2 by 3 standard deviation. So when one value is given and the other is asked, you can use this interrelationship to find out the missing value. Okay, so if they give you mean deviation and ask you quartile deviation, you need to convert it to SD, standard deviation first, and then find the quartile deviation. Is that clear? Okay. Second, always remember the deviation from arithmetic mean will be 0. Sigma x minus x bar will always be equal to 0, which is sum of deviations from arithmetic mean will always be 0. Okay, whereas when we speak of absolute deviations, sigma x minus x bar within the modulus, this cannot be 0 because negative is not there, so this cannot be 0. This will be minimum when taken from median, which is, instead of using x bar here, if I use median, then the observations will have the minimum deviations, right? Third most important property to remember is going to be your change in origin and change in scale. Now, change in origin na enadhu addition or subtraction of a given value. Okay, and change in scale na multiplication or division of a given value. Very important here, the normal equation is y is equal to a plus bx, whereas for dispersion, okay, we are going to use y is equal to modulus of b into x. Why? Because measures of dispersion is not affected by change in origin. It is affected only by change in scale, only to the extent of value, not sign. Okay, only to the extent of value or magnitude. Okay, not sign or direction. So remember, dispersion is affected only by change in scale and not by change in origin. Right? Now, let's understand. Very repeated question under your measures of dispersion. Okay, so that I am targeting that questions for that set of question first. If relationship between x and y is given as 4x plus 5y equals 7. Okay, and mean deviation of x is 1. Calculate mean deviation of y. Okay, now how to calculate? First remember, converted it to the general format. So 5y is equal to 7 minus 4x, or y is equal to 7 by 5 minus 4 by 5x. Now we need to take only the value of b. Okay, for dispersion we will not take the entire equation, we will only take the value of b. What is b? Minus 4 by 5. Now we are going to take mean deviation of y is equal to modulus of minus 4 by 5 into x, mean deviation of x, which is 1. So which is 4 by 5 into 1, answer is 4 by 5. It is only modulus of b into x, remember. Okay. Now in the same question, if they give you same equation, let's take coefficient of variation is 50 and arithmetic mean is 10. Okay, arithmetic mean is 10. Calculate coefficient of variation of y. Now remember friends, this equation of y is equal to modulus of b into x will be applicable only for absolute measures, which is range, mean deviation, quartile deviation and standard deviation. So coefficient they have given, you cannot apply the formula directly. I need to first find out the standard deviation. Apply the formula to standard deviation and then only convert it to coefficient of variation. So let's first find out standard deviation of x. How to find out standard deviation of x? Coefficient of variation 50 is equal to standard deviation divided by arithmetic mean into 100. So therefore, what is standard deviation of x? 5. Standard deviation of x is equal to 5. Now when I say standard deviation of x is 5, now I can use the formula of standard deviation of x and y related as y is equal to modulus of b into x. So same formula I am going to use. So here the equation is y is equal to 7 by 5 minus 4 by 5x. What is relevant? This minus 4 by 5 alone is relevant. So what we are going to do here, we are going to take standard deviation of y is equal to modulus of minus 4 by 5 into x, which is 5. So minus will be ignored. So 4 by 5 into 5, which is 4. Standard deviation of y is equal to 4. Now we have found out the standard deviation of y, whereas we need the coefficient of variation of y. To find out the coefficient of variation, let me continue here. I need arithmetic mean of y. Now friends, to find out arithmetic mean is a measure of central tendency. We cannot use I'm sorry. Okay, so the note has died. Let's redo the working. So we found out that SD of x is 5. Substituting in the equation, we got SD of y is equal to modulus of minus 4 by 5 into 5, which is 4. Okay, now coming back. Yeah, so to find out arithmetic mean of y, it's a measure of central tendency. So we are not going to use modulus of bx formula. We are going to use y is equal to a plus bx formula. I don't know what is the issue with this. Okay, so I write it afresh, doesn't matter. So for arithmetic mean, we are going to take y is equal to a plus bx formula. So the equation is y is equal to 7 by 5 minus 4 by 5x. Okay, and we know what is the arithmetic mean of x, which is 10. Therefore, we are going to take y is equal to 7 by 5 minus 4 by 5 into 10. So what is the value of arithmetic mean here, friends? 40 by 5, which is 8. Okay, so 40 minus 7 is 33. Minus 33 by 5 will be the arithmetic mean of y. Remember, measures of central tendency can be negative. Measures of dispersion cannot be negative. Okay. So now coming to calculate the coefficient of variation of y. How to find out? Standard deviation 5 by arithmetic mean 33 by 5 into 100. When you find coefficient of variation, you can ignore the sign, that is not a problem. So you will get 25 by 33 into 100, whatever is your final answer. What is the answer? By 33 into 100. You will get 75.75 or 76. That is your final answer for coefficient of variation of y. Okay, so when you are going to find out a relative measure, you need to use the absolute measure to convert the relationship. Then only you can find the relative measure. Do not apply the equation y is equal to modulus of b into x directly into the coefficient value. Answer will be wrong.
Ma'am, here it is 4 by 33 by 5 no ma'am. SD of y is 4 no.
Oh, SD of y is 4, my bad. Okay. Yes. SD of y is 4. So 4 by 33 by 5, which will give you 20 by 33 into 100. Which is how much? 60.61. 60.61. Right. Okay. Now similarly, they can also ask you variance of x is say 36. What is variance of y? Again, you cannot apply the formula y is equal to modulus of b into x directly on variance. What should you do? I should first convert this into standard deviation. If variance is 36, then what is standard deviation? Standard deviation of x will be 6. Convert into standard deviation, then use the formula y is equal to modulus of minus 4 by 5 into 6. So you will get 4 by 5 into 6, which is how much? 4.8.
4.8 ma'am.
Yeah, 4.8. Now, 4.8 you need to square, therefore variance of y will be 4.8 the whole square. Okay, so which will be 23.04. Do not apply directly 36, do not multiply as say minus 4 by 5 into 36, your answer will be wrong. Convert it into the absolute measure. The formula will apply only for absolute measures and not for other measures of dispersion. Okay, so very important question from dispersion area. They can ask you this change in origin and change in scale, especially in the coefficient questions. Coefficient கொடுத்துட்டு கேட்கிறது or variance கொடுத்துட்டு கேட்கிறது is a very frequently tested area. Clear, friends? Okay, otherwise the formula application of formula is all direct, so I am not getting into those questions right now. Right? So this summarizes your discussion on dispersion. Now before we conclude, there are certain combined measures that you have to remember. Now combined measures, you have these two important formula. One is combined arithmetic mean formula. What is the combined arithmetic mean? Where arithmetic mean of two groups or more is given and you want to find out the combined arithmetic mean, which is n1 into x1 x bar 1 plus n2 into x bar 2 divided by n1 plus n2. They can give you either the combined value or individual values and ask you to calculate the combined value, right? Now remember, whenever the question n1 n2 is not given in the question, assume total n as 100%. Again, okay. So when the n1, n2 is individually not available, assume total n is 100%. So you can take n1 is equal to 100 minus n2 or n2 is equal to 100 minus n1 anyways and substitute and solve. Similarly, they can also test you on combined standard deviation. Okay, which is root of n1 into variance 1 plus n2 into variance 2 plus n1 into d1 square plus n2 into d2 square divided by n1 plus n2, where d1 is nothing but standard difference between the arithmetic mean 1 and combined arithmetic mean, and d2 is arithmetic mean 2 minus combined arithmetic mean. V1 is nothing but variance 1, which is standard deviation square, and V2 is variance 2 standard deviation 2 square. Okay, so in this case I need to find out combined arithmetic mean, find the difference between the given arithmetic mean and combined arithmetic mean and take the square for D1 and D2. Okay, these are the two combined measures that can be tested. Adliyum frequent testing is going to be on combined arithmetic mean question. Okay, right? So this summarizes your formulae and concepts on measures of central tendency and dispersion. Okay, you can practice the questions from set B, set C, and mainly additional question bank also I hope you have practiced. Now more importantly, for theory questions, Just remember the concepts that we have discussed in class, that we have revised right now in class, and using that attempt the theory questions. Theory questions are going to be practical application or application of what we learnt as concepts. Okay. Set A questions pattern and some of your additional question bank that we would have discussed in classes will also be sufficing for your theory area. You don't have to look into your material for any theory aspects. Just revise the concepts notes that we have done in the class. Right? So these aspects will help you to cover your theory portions as well. So this summarizes your part 1 or the major area of discussion under statistics syllabus, which is your central tendency and dispersion. Right, friends? Any doubts? Okay, so take your break. We will resume in 20 minutes and we will continue with the next chapter, and we are going to start off with correlation and regression next. Okay, so take your break and we will resume in 20 minutes, 20 to 25 minutes.